Hi, this is Mel. Today I want to go through some of the transformation example with you. And yeah, this is chapter 7E. Let's talk about example 8. Okay, so find a sequence of transformations that takes the graph from quadratic form f1 to f2. So the textbook have a very tricky way to do it. I'll say it's tricky because they factorize it first. So we have x plus 1 to the square plus 5 and 2 times, because we want to take the 2 out, into 2x squared plus 4x plus 5, and then you do the factorize. Take the 2 out and square and minus 3. Okay, so now we have the initial function in terms of the square and the final function in terms of the square. Then we want to move the 5 and the 3 to the left hand side to make it better looking at the right hand side. We're leaving only a square, and left hand side only y, right hand side only x. Okay, now because we want to know the transformation from initial to final, then we can correspond the y part, this part, with the y part, y prime part. So the initial part of the y and the final part of the y. If we let them to be equal, then we get a function. Y prime is equal to 2y minus 13. And the x part, after factorizing, you'll see it's very easy to write an equation, x plus 1 and x prime plus 2. So we get x prime equal to x minus 1. So now we can say the transformation. So the transformation is a dilation of 2 from from the x-axis. Because when we are talking with the equation of y, we're actually doing dilation. If it's dilation, then we are actually doing it on x-axis. But for the translation in this y equation, we are talking about y. So 13 units in the negative direction of the y-axis. And a translation, 1 unit down on the x-axis in the x equation. So this combines like how to factorize and how you interpret the transformation with the equations from the initial and final x and y. Okay, this is example 8 and example 9. So we have fx is equal to x squared. Write the equation for the graph y equal to 4fx plus 3. So we just substitute x plus 3 in there, in the x, and 4 times it in front of the x. So we have x plus 3 in this under the square. That's part A. And part B, give a sequence of transformations that takes the graph y equal to fx to the graph y equal to 4fx plus 3. So how are we going to map this function to this function, the initial to the final function? We can rearrange the final function divided by 4, and that's the y part. And we also write 2 equations, which corresponds the x with x prime plus 3 and the y prime on 4 with the y. And that's the two equations. And it gave us x prime and y prime. And you can do the transformation. That is dilation of 4 on the x, because we're in the y function. And when talking about translation, it's about the function itself. So in this one, it's about x. So translation of 3 units in the negative direction of the x-axis. So let's directly look at the summary of chapter 7. So it tells about the mapping, like the steps, the reflection, dilation, translation, and the rule, so the coordinate form, and the graph in terms of f. So personally, I think this is a bit vague, so it's more important to do some practice. And I also have another video which is about year 12 transformations, but I think that will help. That will help definitely. So refer to my the other video of mine, and yeah, that's it for today.